right, here we go with objective 33. This is the second to last objective of the semester and of the unit. This is determining the graph of a linear equation in any form. So I alluded to this earlier in the unit when we talked about x and y intercepts, that we can graph any equation, linear equation, by finding the intercepts and then plotting them and then connecting the dots. And that's exactly what we're going to do today. So the procedure here, step one, is to find the x-intercept. And as a reminder, to find the x-intercept algebraically, we set y equal to 0 and we solve for x. Likewise, step 2, find the y-intercept. The process algebraically is quite similar. We're going to set x equal to 0 and then solve for y. Once you have the x and the y-intercept, step 3 is to plot the points and graph a line. Just connect the dots. And this works for any linear equation. Find the intercepts and connect the dots, plot them, connect the dots, and you got a line. This works for any linear equation. So here we've got this equation here, 4x minus 7y equals 28. You may recall from last objective, this is in standard form. Let's go ahead and write that just as a reminder. This is in standard form because all of the x's and y's are on one side of the equation, and all the constants, the numbers, are on the other side. So then, to find the x-intercept, that's where y equals 0. We're going to set y equal to 0. So we have 4x minus 7y. Well, y is now 0, so 7 times 0 equals 28. So now we can just solve for x. So 7 times 0 is 0. So we have 4x minus 0 equals 28. Well, 4x minus 0, subtracting 0 doesn't change that at all, so it's just 4x equals 28. And then our last step, we want x by itself, so we divide both sides by 4. So we have x equals 28 divided by 4 is 7. So our x-intercept as an ordered pair is 7, 0. To find our y-intercept, we set x equal to 0. So plugging in 0 for x, we have 4 times 0 minus 7y equals 28. 4 times 0 is 0, and then we'll bring down the rest, minus 7y equals 28. Well, 0 minus 7y, we don't really need that 0. We can just leave our negative 7y equals 28. One more step, we divide both sides by negative 7. So we have y equals 28 divided by negative 7 gives us negative 4. So our y-intercept as an ordered pair is 0, negative 4. So we're going to plot each of these 2 points. So our x-intercept, 7, 0. So from the origin, we'll count right 7. 1, 2, 3, 4, 5, 6, 7. So that's our x-intercept. Our y-intercept is negative 4. So from the origin, we'll count down 4. 1, 2, 3, 4. We've got 2 points. Get your straight edge or ruler ID and connect the dots. And don't forget, this is a line, so we should see arrowheads on either side of your line. And there you go, we just graphed the line. Let's try another example. So this one here, you might recognize what form this is in. This is in point-slope form. All right, so to find the intercepts, we do the same thing. So the x-intercept is where y equals 0. So we're going to plug in 0 for y. So we have 0 minus 2 equals negative 3 times x plus 2. Okay? And then solving for x, well, 0 minus 2 is negative 2. And then we'll distribute our negative 3. So negative 3 times x is negative 3x. Negative 3 times positive 2 is negative 6, so minus 6. To get x by itself, we got to deal with this subtraction, minus 6. So we're going to add 6 to both sides. And so we have negative 2 plus 6 is a positive 4 equals negative 3x. And then we divide both sides by negative 3. So we have x equals, well, 4 over negative 3, that doesn't reduce, so we're just going to leave it as negative 4/3. When we're graphing this, it might be helpful to find a decimal approximation. So you can plug that into your calculator. Negative 4/3 is approximately equal to negative 1.33333, repeating. So negative 1 and 1/3. So as an ordered pair, we're going to say that our coordinate is negative 1 and 1/3, 0. All right. So now let's find the y-intercept. That's where x equals 0. So we're going to plug in 0 for x. So we have y minus 2 equals negative 3 times, and this is where we plug in 0, 0 plus 2. And I'm using parentheses here. All right. Well, let's do PEMDAS, order of operations. So 0 plus 2 is 2. And then we'll just bring down the rest. So times negative 3, and we'll bring down the y minus 2. Well, negative 3 times 2 is negative 6. And we'll bring down the y minus 2. And then our last step, we're going to add 2 to both sides. And we get y equals, well, negative 6 plus 2 is negative 4. So our y-intercept is negative 4. As an ordered pair, 0, negative 4. So we're going to plot each of these points. Our x-intercept, negative 1.33, 0, tells us from the origin we're going to go left 1 and a little bit more. So that's that 1.33. So it should be right around there. You can just kind of approximate. And then here we have negative 4. So 0, negative 4. So we're going to count down 4. So 1, 2, 3, 4. That gives us this point. That's our y-intercept. We're going to connect the dots, and that gives us our line. Again, with arrowheads. All right. So this method works for any line in any form, any linear equation. We can just find the intercepts. Set x equal to 0, solve for y. Set y equal to 0, solve for x. And then plot those points and connect the dots. This works for any linear equation. So this is a very useful tool. All right, we're going to get a lot of practice on this. This is our second to last objective. We got one more for the semester. All right, have a great day, everyone.